Welcome viewers, in this video we will see the solved problem based on the Cartesian product that is coming under sets, relation and function, one of the mathematical topic. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic. We'll see the problem. In a survey of 5,000 persons in a town, it was found that 45% of person know the language A, 25% know language B, 10% know language C, 5% know languages A and B, 4% knows languages B and C, and 4% knows language A and C. If 3% of person know all three languages, find the number of person who knows only language A, right? So by using the sets we can solve this problem. This problem can be solved by either property of cardinality or the Venn diagram, right? So we in this problem we solved both cardinality as well as Venn diagram. Both are available in this video, right? So we'll see the problem once again. There are 5,000 person in a town. 45% know A, language A, 25% knows language B, 10% knows language C, 5% knows A and B, 4% knows B and C, another 4% knows A and C, 3% knows both all three languages A, B and C. Now we'll go to the problem. First we will see the cardinality method. So from the given data we will find in this problem the percentage is given. Now we need to find the numbers. Total 5,000 persons available in the town. From the given percentage we need to find number of person knows language A, B, C, like that we need to find the numbers. First we will find the language A. 45% of persons knows language A. So 45% means n of A. We will take n of A equal to 45% of 5,000. 5,000 is the total population of the village. So language A 45% means 45% of 5,000. That is 5,000 divided by 100 into 45. So we will got 2,250. So 2,250 persons knows the language A. Similarly 25% of person knows language B. So that n of B equal to 25% of 5,000. That is 5,000 divided by 100 into 25. That is 1,250 persons knows the language B. Then 10% of person knows the language C. That is n of C equal to 10% of 5,000. Total population 5,000, in that 10% knows language C. So 5,000 divided by 100 into 10, that is 500. So 500 persons knows the language C. Now we'll go for the remaining calculations. Remaining calculation, 5% of knows languages A and B, both language A and B. So that n of A intersection B, the A and B common to A and B knows the language A as well as language B. 5% of 5,000 is 5,000 divided by 100 into 5, that is 250. Right. Then 4% of knows language B and C, that is n of B intersection C. That persons knows language B as well as C. So 4% of 5,000. 5,000 by 100 into 4, it is 200. 200 persons knows B and language B and C. 4% knows language A and C. So n of A intersection C equal to 4% of 5,000. 5,000 divided by 100 into 4, that is 200. So 200 persons knows language A and C. Then 3% knows languages A, B and C, all three languages. So n of A intersection B intersection C equal to 3% of 5,000, that is 5,000 by 100 into 3, that is equal to 150. So 150 persons knows language A, B as well as C. So now we calculated the number of person. For the given percentages, we calculate the number of person. Only language A, language B, language C, A and B, B and C, A and C as well as ABC. All three languages, all are calculated. So the question is the number of person who knows only language A. What we need is only language A. They don't know language B and C. So that is nothing but n of A intersection B dash. B means knows the language B. B dash means don't know the language B. Intersection C dash. Similarly, C means the persons who knows the language C. C dash means the person don't know the language C. So that only the person, number of persons knows only language A, don't know the language B and C, right? So this one can be written as n equal to A intersection B union C dash, right? So this B dash intersection C dash can be written as B union C dash, right? That is B and C, language B and C they know, dash means they don't know. B union C means the B union C is nothing but the number of persons who knows the language B as well as C, right? Language, both the languages. Dash means they don't know the language B and C, right? So that case, this another further you can written as n of A minus n of A intersection B union C. This B union C dash can be written as A intersection of B union C, right? So the B union C dash is written like that. So further it can be written as n of A minus n of A intersection B, n of A intersection C plus n of A intersection B intersection C, right? So this formula is again expanded, right? So what we have, n of A minus n of A intersection B minus A intersection C plus n of A intersection B intersection C, right? So these values are already calculated. N of A, the person who know language A is, one language A is 2250 minus n of A intersection B is 250. That is the person knows both language A and B, right? So we need to subtract these 250 persons knows A as well as B also, but what we need only A. So this is subtracted. So another 200. These 200 is nothing but these persons knows A and C. They know A as well as C, but what we need is only A. So these 200 also subtracted from this. Plus 150. The persons know all three languages, A as well as B as well as C, right? So that can be included, right? So this one know A language A. The number of persons only they know language A, right? So 2250 minus 250 minus 200 plus 150. So while adding what we got, 1950. The 1950 persons knows only language A. The number of persons who knows only language A is 1950, right? So by using the cardinality method, we calculated the value 1950. Now we'll go to the Venn diagram. By using the Venn diagram also we can get the answer. We'll see the Venn method. So now we'll see the Venn diagram. We draw the Venn diagram using the percentage, right? So this green color represents the language A, red color language B, blue color language C, right? So from the given percentage we can fill the data one by one. 45% of population knows language A. The language A is known by 45%, but they will know the B and C also, right? So we don't know how many of them are know the language A alone. This person knows language A. Maybe they know the language B and C also, right? So it is written outside, right? So this area is nothing but the person who knows language A, B and C, right? A intersection B intersection C is this area that is given 3%. The number of persons, the percentage of persons knows language A, language B as well as language C is 3%, right? So that it is filled in the common area, A intersection B intersection C. Then A intersection B, the percentage of population knows language A and B is known as 5%. right? So this area, the common between A and B, 5%. In that already 3% is filled. So 5 minus 3, 2%. This 2% knows only A and B. These 3% know A, B and C. So that it is 3 is given here. Now the number of number of percentage of population knows A and C. A and C is 4%. That is this area. A intersection C. This area is 4%. Out of 4%, 3% is already filled. So 3 minus 4, 4 minus 3, it is 1%. So 1% knows A and C. In that 3% know A, B, C. Right? So now the data are filled. Right? So language A known by 45%. These 3% knows, percentage of population knows language A, B and C. These 2% knows A and B. Total 5%. In that already 3% is filled. So 5 minus 3, 2%. A and C, 4%. So 4 minus 3, 1%. This 1% of population knows A and C. These 2% knows A and B. Out of that, 3 knows all 3, A, B, C. Now we'll fill the remaining area. The number of percentage of person knows only A. Right? So total 45. From that, if you subtract this value, we'll get only the remaining area. So 45, this is nothing but 1 plus 3, 4, 4 plus 3, 6. So this 6% should be subtracted from 45. 45 minus 6 is 39. So 39% of population knows only A. Right? Out of 45, 35 knows only A. 35 in that this 2% knows A and B. This 3% knows A, B, C. This 1% knows A and C. So all are subtracted. This 39 knows only the language A. Right? So the given problem 45% is given as language A. In that we subtracted 2, 3 and 1. That is total 6. 45 minus 6 is 39. Right? So from the Venn diagram, the percentage of persons who knows only the language A is 39. We calculated 39. So this is the percentage. We need to find the number. Therefore, the required number of person is 5000 divided by 100 into 39. That is 1950. The same answer we got in the previous method also. So the number of person who knows only language A is 1950. So in this video, we solved the problem based on sets and relation. We solved the problem based on the two method, cardinality method as well as Venn diagram. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening.